All right, number 1. It says, a ball is dropped from an initial height of 5 feet. The ball bounces and rebounds to a height of 70% of its previous height. The ball bounces in the same way many times. The function that could be used to model the nth term in the sequence of the height of the ball is blank. So, important information I want you to underline. I want you to underline initial height of 5 feet. I want you to underline 70% of its previous height. And I want you to underline nth term. Okay? Alright, so just by looking at this problem and the operation sign that it includes, is it going to be arithmetic or geometric? It's going to be geometric. Why, Caden? Because it is multiplying. So just jot down that this is a geometric. All right. So geometric. What comes first in a geometric sequence? What term? What's the only term you know? Not in. The first term times the common ratio.
0.7.
Okay, yes. And then what goes at the top?
N minus 1.
N minus 1. All right, so what is the first term? 5. That's what it tells us right here. The common ratio is 70%, but Danny said we changed 70% to 0.7. And it's asking for the previous. What's the word previous mean? The one before it. So we have to use n minus 1 to get the previous term. Okay. Questions on geometric. This is the geometric formula. Okay. You don't need to remember these numbers. You need to remember the formula and how to use the numbers. Okay. All right. Number 2. Consider the following sequence: 1, 7, 15, and 25. Let n represent the position of the term in the sequence, starting with n equals 1. Which function defines this sequence? All right, I don't know. A couple weeks ago, we talked about which one mattered most, x or y. Which one was it?
Y.
The y. So what do you think these values are right here? They're the y values, okay? So what this means, I want you to create a chart with this sequence of numbers. Now right below that, it tells us n equals 1. So when I put in a 1, I better get out a what? The first one. A 1, yeah. When I put in a 2, I get out 7. When I put in 3, I get out. And when I put in 4, I get out 25. Okay? So now we have to determine dysfunction rule. So there are a couple of ways we can do this and things we can eliminate. So let's start by determining what type of function this is. Okay? From 1 to 7, what do I do? Okay, I add 6. From 7 to 15, I add. And from 15 to 25, I add. All right, that's considered what difference? The first difference. Are those constant? Nope. They have a constant rate, but they're not the same number, right? From 6 to 8, what do I do? 8 to 10. All right, now the second difference is what? It is plus 2. It is the same. So think back, I don't know, second day of class. Which function means the second difference is the same? Linear, exponential, quadratic? Quadratic, okay? So, out of your options, I guess, we can get rid of the ones that are not quadratic, right? My answers are probably in different order than yours. So, what 2 can I get rid of? That's a quadratic, though. This linear, n plus 4, n plus 6. Now, if you didn't know that, you didn't know what that meant, you could say, you could say 1 plus 4. What's 1 plus 4 equal? But when I put in a 1, what am I supposed to get out? 1. Is 5 the same thing as 1? No, so that's why that first one didn't work. Now the one to the right of it is n plus 6. Well, what's 1 plus 6? 7. So, is that the same thing as 1? Nope. So we've marked this and this. Now we've got these quadratics. You can do this 2 ways. You can plug in numbers 1 through 4 and make sure you get out these numbers. Or, what can you do with each function? Where can you put it? Where can you put it in your calculator? Where at in your calculator? Your y equals. So, go ahead and everybody put in this first one in their calculator in the y equals. All right, so the first one, does the first one match? All right, the first one does match. Does the second one? No. What does it say on your calculator when you put in the 2? That says you should get out what? 8. This one says 7, so that's not right. Okay? So now, obviously we only have one left, but let's try. So put this last one in your calculator in your y equals n squared plus, or x squared plus 3x minus 3. All right, so here, when you put in a 1, do you get out a 1? Yes. All right, when you put in a 2, did you get out 7? Yep. When you put in 3, did you get out 15? Yep. And when you put in 4, you got out 25. All right, so let's say we don't want to use the calculator. What can I do? Can I physically plug in a 1 and physically plug in a 2? So let's just do a 3. So we have 3 squared plus 3 times 3 minus 3. All right? Well, what is 3 squared? All right, so we got 9 plus 3 times 3. 9 minus 3. Well, 9 plus 9 is 18, minus 3 is 15. Now, if you're going to do it this way, when you plug in a number, what's around the numbers that I plugged in? What's around them?
Parentheses.
Parentheses. You have to use those parentheses. Most of the time, it will not matter. However, you always want to be safe because it might make a difference. Okay. Now, what? Well, I'm jumping ahead. Let me wait. Let me show you. All right. Number 3. Let's look at it. Not that. Okay, right here. Same thing. Let's make us a chart. Our Y values are what is listed. So we've got 3, 7, 11, 15, and 19. Now, we are trying to get a table, okay, that matches mine. Just looking at your answers, before we even start, there is one answer choice that is straight up weird. Which one is it? Which one is that?
4n plus 19.
All right, 4n plus 19. Yes, absolutely. We're starting with 3. Or we're starting with 1 and we got to get out of 3. There is no way that's possible. So let's do process of elimination and just go ahead and mark that one out. All right, now when we put in a 1, what's my table say? I have to get out what? I have to get out 3. So let's do the easy one. The one right here, n plus 4. Well, 1 plus 4 is 5. Is 5 the same thing as 4? Nope. So we can mark it right on out. And then we have these other 2. Let's just start with 2n plus 1. 2 times 1 plus 1. What is 2 times 1? Plus 1 is... Does that work? Yep. Does that mean it's the answer? No, we should probably try the other one just to be sure. All right, so 4 times 1 minus 1. Well, 4 times 1 is 4 minus 1 is 3. Oh, gosh. What have we run into? They both what? They both work. But just because the first one works, does that mean the other 4 x values work? No. So we must try again. So this time, let's plug in 2. 2 times 2 plus 1. Oh, well, that says when we plug in a 2, we're supposed to get out a what? 7. So that's not what? That's not it. So, yes, we have one answer left, but let's make sure. 4 times 2 is minus 1. Is that correct? Yes. So 4n minus 1 is correct. Emmanuel is starting a cycling training program. He will start cycling a short distance and increase his distance over time. Emmanuel will cycle 5 miles during the first week and increase his distance by 2 miles each week. The table shows his training plan for the first 7 weeks. Write a recursive function that defines the number of miles Emmanuel will cycle during the nth week. Okay. What does this right here mean? F of 1? Okay, yeah, f of x means y equals, all right, but it does mean the same thing. That 1 is in place of which letter? X. So look for 1 on the x column. What does it say the y is? 5. That is because f of 1 means the first term, and it tells us right here 5 miles during the first week. Okay? Now, we have to write a recursive function. So, looking at this table, what is it doing every week? He's increasing by what? He is increasing by 2 every week, which is what he told us right here. So we've got 2. Is this going to be an arithmetic or geometric sequence? Arithmetic, because what am I doing every time? I'm adding. So we have 2 plus. Now, recursive. What does recursive mean? You have to know the what term to get the current term. Not the first. Well, it can be first and it can be second, but I have to know the previous term to get the first term. Okay? So look at your weeks. Are they increasing every week or every 2 weeks? Every week. So what has to go right here? F of n minus 1 or f of n minus 2? F of n minus 1. Now, the full function rule. This is an important thing you need to write. This is for arithmetic. First term plus the common difference times n minus 1. So these 2 things that we've done right here is split it up. So we want to put it all together. So what is the first term? Well, how many miles did we get in week 1? 5 plus, what's the common difference? Every week it's adding what? 2 times n minus 1 was a formula that I told you had to know.
The geometric.
Bingo. The geometric sum. So Sn equals T1 times 1 minus r to the n divided by 1 minus r. Given a series of 64 plus 96 plus, 144 plus 216 plus ... Okay? Common ratio is r. That's what it tells us right here. And we're looking for the sum of the first 10 terms. So in this equation, what do you think that big S stands for? It stands for the sum. All right, so we got S. And the N is the number of terms I'm looking for. What did I just say? The sum of how many? 10. Equals T1. What term is that? First. What is the first term in that sequence? 64. Good. Times 1 minus r to the n over 1 minus r. Now, we haven't found r yet. There's 2 ways you can do this. You can multiply frontwards, or we can divide backwards. Okay? So, Jacqueline, I want you to type in 216 divided by 144. Jack, I want you to type in 144 divided by 96. And Kaylee, I want you to type in 96 divided by 64. Divided by 144. All right. Jacqueline got 1.5.
1.5.
All right, Jack got 1.5.
1.5.
Kaylee got 1.5. All right, so what is our common ratio? 1.5. So we can fill that into our equation. Now, I'm missing one thing on my equation. On the right, what am I missing? I'm missing the n. So that top 1.5 in the numerator needs to be raised to the power of n, which is 10. Okay? Now, important part. If necessary, round to the nearest thousandth. Okay? So now I want you to take about 30 seconds and type in this equation into your calculator, and you'll get a number, a large number. Once you have it typed in, raise your hand. I want to make sure you have it typed in correctly. That I checked had 7523 or 7.
7253.
All right, 7253.125. Now it says round to the thousandth. What place is the thousandth? Yep, to the fifth, to the number 5. Tenths, hundredths, thousandths. Now, if you just put that right there, would I count it wrong? No. Would the state and the EOC count it wrong? Absolutely. Is the ACT going to count it wrong? Absolutely. Is any other person in test going to count it wrong? Absolutely. Okay? So you have to really pay attention if it tells you to round on something. Okay? All right. Number 6. All right. Which of the following functions describes the sequence? So look, we have a chart. Okay? Your answer choices are probably out of a different order than what mine are. So, Alyssa, I want you to type in this first one. Okay? Allie, I want you to type in the second one. Ava, I want you to type in the third one. Brenna, I want you to type in the fourth one. And Bo, I want you to type in the last one. All right, so how we can do this the most efficient way is to use our calculator, okay? Which of the following functions describe the sequence? Select all that apply. I'm going to underline. Select all that apply, and this is Miss Ellery's rule. On any problem I ever give you, any test, any quiz, anything, and it says select all that apply, and you only select one answer, y'all know what I'm going to do? I'm going to count it wrong just because. Because what does the word select all mean? That means you at least have to have how many?
41.
You have to have more than one. Otherwise, it wouldn't say select all. Okay? So, even if you only know one of those answers, you still better take a good old guess and circle 2. Okay? So, right here, we're going to have at least 2, if not 3. Okay? So, Alyssa, when you type this in, if you look at your table, when you put out a 1, do you get out a 6? Huh? What do you get out? a 3 because 3 to the 1 power is 3. Okay? We could look at this one and just say, well, 3 squared is what? 9, but it says it is 18. So that's not right. All right, Allie. 2 times 3 to the x and your y equals. When you put in a 1, do you get out a 6? No? Are you sure? You did 2.3. 2 times 3 to the x. Alright, so make sure you do, if you put that one in, it's 2 times 3, not 2.3. So now, Allie, looking at that table, does it match the one on the board? 1, 6, 2, 18, 3, 54, 4, 162. Yes. So this one is an answer. Okay. Ava, the third one. Yes or no? It does match? Okay. I agree 6 to the 1 matches. But when you put in a 2, you get out an 18?
No.
What do you get? 36. So here's what I bet you did. I bet you saw, oh, well, 1 works. And you marked it, didn't you?
I didn't mark it.
Huh?
I didn't mark it, but yeah.
Okay. So they have to all work. Okay. So this one does not work. Brent, 6 to the x. Brenda, what about the third one?
It does.
It does work. So when you put in a 1, you get 6.
I think they get a 3.
Well, if it works, then you're supposed to get a 6.
I lied. Sorry. I looked at 6 and I looked closer to 3. I lied. I'm sorry.
Bo, this last one. 2/3 times 3 raised to the power of x plus 1. Does the first one work?
Yep.
Does the second one work?
Yep.
Third one?
Yep.
And the fourth one? Yep. All right. So now, when Brenna gets hers typed in, we'll look at the other one. All right. Now that you have it typed in, does 1 say it goes with 6?
Yeah.
2 says 18. 3 says 54. And 4 says 162. Yes, so since all 4 of those work, Brenna's is also an answer.
What is this one?
This one right here says that the common difference is 61. But what does it tell you up top? 61 is what term? The 12th term. So can I mark this one out? Yep. All right, now we have to decide between 11 and 5. So, do you remember this? Remember that? Slope with 2 points. All right. So, for this 6, it would be 1 comma 6 because it's the first term. And this one would be 1261. Okay? So if I plug those in, y2 would be 61. Y1 would be 6. X2 would be 12. And X1 would be 1. What is 61 minus 6? What? 55. 12 minus 1 is 11. Well, 55 divided by 11 is. So, what is our common difference? How do I get what? Because it is the first term. The 1 is because it's the first one. And then just like we use 12, that's because it is the 12th term. Got it? All right, questions? All right, number 8. Now, here's another problem using that geometric sum. Okay? So, a book chain store sold 10,000 copies in its first month. Historically, she falls by 20% each month. Which of the following could be used to determine the number of books sold in the first 6 months? All right, so what is the first term? How many do I sell in the first month? I sell 10,000. Do all of your answer choices have 10,000 in them? Yep, so we can't mark out anything. Okay? Now, how many months am I looking to find? 6. So, can I mark out the ones that say 24? All right, now think back to the problem we did a minute ago with the 64, 96, 144, and 216. That rate that we included on the top and the bottom, was it the same or was it different? It was the same. So what can I mark out?
The one that got 8 and 0.8 at the top of 0.2.
Yes, the one that has 0.8 here and 0.2 at the bottom. Now, this is where you might get confused. You have to really pay attention to this word, fall. What does the word fall mean?
Goes there.
Dropping, goes down, decreasing, okay? So, if we have 100% and we fall by 20, how much do we have left? We only have 80%. So, what will be correct when I use 0.2 as my rate or 0.8 as my rate? 0.8, because it tells us it falls by 20%. If it just said 20%, yes, it would be 0.2. However, you have to pay close attention to where it says fall. So it's decreasing by 20%. So like when Janiyah is playing basketball, if she's shooting 100%, has she missed any shots? No. Okay, well, then let's say one night she has a little off night and she misses her shots by 20%. Well, still, even though she missed 20% of her shot, how much percent did she shoot? She still shot 80%. Okay?
Fall is like 100%.
Do what?
So fall is just 100%. And you just subtract that from.
Yes, you're just following that 20 from 100 because that's a whole percent. All right. Number 9, our inverse. Okay. On our bell work, we determine to find the inverse, we do 2 things. We swap x and y, and then we solve. Okay, so let's just start with linear. Can you really change a straight line? No, you can either make it go positive or negative, but you can't do much with it. Okay, so let's algebraically find the inverse. So y equals 2x. First of all, before we start, what are the 2 and the x doing? They're multiplying. What is the opposite of multiplying? Dividing, so just keep that in mind. First, I swap the x and the y. Then I solve for y. So what do I do with the 2? I divide. So the inverse of 2x is x over 2. You can look at that and you can, if you see it this way, great. If not, great. you can look at this, or I look at this and I see that 2 and x are multiplying. Well, I know the opposite of multiplying is dividing, which is what x and 2 are doing in the inverse. Okay? Now, what is the opposite of squaring? Square rooting. So, what is the inverse of x squared? If the opposite of squaring, which is what I'm doing right here, is square rooting, then the opposite of x squared is the what of x? The square root of x. So just like before, y equals x squared. Swap the x and the y. To get rid of a square, you take the square root. So the square root of x is now the inverse. Okay? Now another one you should already know is the inverse of an exponential is a what base? It's a what?
A log.
A log. So just jot this down. Y equals b to the x changes to y equals log base b of x. So in this particular problem for exponential, what is the b value? 2. And what is the x value? Just what? Just x, yeah. Alright, the bottom part says, when graphed, a function and its inverse are reflections across what line? Y equals x. That is because I can have a reflection over the x, and I can have a reflection over the y. All right, number 10. It doesn't tell you what to do, but what do you notice every answer has? F minus 1. And what do we know that means? The inverse. So what am I going to have to do to this function right here? Find the inverse. F of x is also known as y. So first I'm going to swap. Then what will I do?
Cancel the 4 out.
Yep, cancel the 4 out. It's by subtracting 4. So I've got x minus 4 equals y squared. But how do you get rid of a square? Yep. So the square root of x minus 4 equals y. Now, do you see that answer on there? No. You see f negative 1 of something. All right, that of something, is that something the x or the y? It is the x. So since it has f negative 1 in front, where do you think we have to plug those values? Into the inverse or the original? Into the inverse. Okay? So, let's just start with the first one. What is 5 minus 4? What's the square root of 1? Does the first one work? Or my first one work? I don't know if it's your first one. Yes, it's just a positive 5 and a positive 1.
So does that mean the one that's 29
Correct. Now, the one that says -5 will not work because it says x is what? Then 0. X is greater than or equal to 0. And is that -5 greater than or equal to? No. All right, number 11. First, I want you to find the inverse of this function. 3x plus 14. Once you're done, I want you to put your pencil down. What does f of x mean? All right, so y equals 3x plus 14. Can I start here and start solving? Nope. First, I gotta swap them. All right, next I'm going to add 14 or subtract. Then what will I do? Which one is the only one that says this? I don't know which one it is on your paper.
It is x minus 14 over 3.
What letter is it though? A, B, C, or D? C. Okay. Now, this one right here says x plus 14. This one right here is the exact same thing as what I started. This one right here, they just factored out a 3. And this one right here is not correct, but would be correct if that 14 was over what?
The 3, 2.
If it was over the 3, 2. Yes. So it is C on your paper. All right, we skipped 12, 13. So let's go to 14. All right. Consider the function f of x equals x minus 10 over 4. Select all that apply. We must find the inverse first. Because, look, inverse, 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 and inverse. So if every answer choice contains an inverse, it's probably a good idea to what? Yep, find the inverse. All right, so y equals x minus 10 over 4. When we change that, x equals y minus 10 over 4. Filter it to get rid of the 4 on the bottom. What should I do? Huh? Okay, but how do I take away the 4? But what do I do to both sides? What's it doing right now? Oh, yes, it is swap. But what is the operation doing? All right, what's the opposite of dividing? So multiply by 4 on both sides. So we got 4x equals y minus 10. JJ, what do I do next? To get y by itself. Not multiply. I'm trying to get this right here. Just be y. What's the opposite of subtracting? Okay, so we're going to add 10 to both sides. What's 4x plus 10? Everybody. What? 4x plus 10?
It's gonna be 4x plus 10.
It's just going to be 4x plus 10. Can't combine those because the 10 don't have an x. All right, so which one of those has the correct inverse? Is it D on your paper? All right, so this one, this is not it, obviously. But it says select all. Yikes. So look right here at these two. They both include 2,18. Do you agree? All right, if I told you to find the inverse of this point, what would you do to those two numbers? So,
So it would be them, because if you flip it, it's gonna put the 18 in the parentheses.
yes. Now, the first one does have this correct information, but is the inverse information correct? Nope. Same thing here. It does have it originally, but not the inverse. Okay? All right, number 15, we're getting short on time. So on number 15, I want you to write, refer back to number 10. It is the same exact problem as number 10, except we can stop after we find the inverse. So look back on your number 10. What was the inverse?
X minus 14.
It was what?
Just kidding. Yeah. No, that's 11. Number 10?
Yeah, what'd you put for 10? What was the inverse that we solved?
Oh, f of x equals x squared plus 4. That one?
Yes, what was the inverse of that, though?
Square root of x minus 4 equals 4.
Yes, the square root of x minus 4. It's the same one, okay? All right, number 16. We have to first find the inverse.
And then c is the same thing.
Do what?
A and c is the same thing.
A and C.
I think for 15.
Let me go back.
The square root's not over 4.
Oh, yeah. Make sure it's all the way over on the 4. All right, so I'm finding the inverse. The first thing I want to do is swap them. How do I get rid of that 4? Multiply. So 4x equals y minus 10. What do I want to do next? Add the 10. What is the 4x plus 10? 4x plus 10 equals y. So the first question asks you, what does the inverse belong to? Linear, quadratic, exponential. Is it in the form of y equals mx plus b? Is it in the form of x squared? Or is it in the form of b to the x? Linear. All right, then the second part actually asks you, what is the inverse? Well, you just discovered that. 4x plus 10.
But we have to
So
put
we
equal
write
y
it-
instead.
Not 18, sorry. What?
Do we have to put
Write
the
it that way, because I'm
equal y?
I would.
doing it right.
All right, the last one. What do you do with that 2?
Put it where X is.
Put it where x is. 4 times 2 is? Plus 10?
15.
18. All right, number 18 is the same thing.
One quick announcement, boys soccer players who have not turned in physicals, you must get this done this week. Again, your physicals, boys soccer, must be done this week. Have a great afternoon.
No, 19. All right. First, we want to graph this right here. Y equals x minus 2. Where am I going to start at on my y-axis? What is the y-intercept?
-4.
Not -4. On this right here that I'm fixing to draw. Yep. So I got -2, and then what's my slope? It's not, so if it's not there, it's just 1. So up 1, over 1, up 1, over 1. Now, right now, this black graph that I've drawn crosses at 2 on the x-axis. Do you agree? All right, this first graph that I have crosses where? Huh? At 4. So from 2 to 4, I moved how many units and to which direction?
So sorry, we have one more announcement.
To what?
HOSA Regional Competition winners, Parker Bond, 3rd in Nursing Assistance, Aaron Brookshire, 1st in Dental Technology, Rebecca Mallard, 1st in Medical Assistance, Kendall Taylor, Vet Science. We're so proud of you guys. Good job. These ladies will compete at state level in March. Congratulations.
All right. So why did I put x minus 2? Because it went to the right. All right. Now, the second one, it moves back to the left, to the center, right? So we started here at 2, and we went back to 0. So this is f of x plus 2. All right. Then this other one, it still hits at 2, but it's been what? It's been flipped over the x. Okay? Now, I'm telling you right now, this is an exact question on the test. So, take it or leave it. All right. Number 20. You cannot do this on your paper because you don't have a slider, so we're just gonna describe what it means. Here's the function rule. F of x minus 2. F of x minus 2 means what? right 2. And the plus 5, Danny said, means up 5. Does everybody agree? Yes? Yes? Okay. All right. Number 21. What is this point right here? -3, 4. Okay. Now, here's the function rule. All right. Notice it shows x plus 3. That's because that negative was already what? It was already there, and 2 negatives make a positive. All right. So it says, which function rule will have a graph that is a translation 2 units to the right? Does it say anything about going up or down? No, so we don't touch that y point. We only touch the x. 2 units to the right, it will be where? It'll be right here in -1, 4. So, out of your choices, it has to be the one that says x plus what? X plus 1. Okay? Question? All right, 22. Oh, that's not 22. All right, the red dotted is the original x squared. The blue solid is transformed. We want to know what the function rule is for the transformed. So first, what is this y-intercept? Yep, sorry, we'll go back. 23. What is the y-intercept on the blue line? Or the solid line? 2. So looking at your answer choices, there are 2 things that I can mark out.
The ones that got 0.5 at the end.
Yep, the ones with the 0.5 at the end. Now, the other 2 are the same, except one says it's negative and one says it's positive. It's positive because it's pointing where, Danny?
Up.
It's pointing up. Good job. Question? All right, let's go back to 22. Sorry, I thought I was on 22. Okay. It says, hold on. All right, here's the function rule right here. The one we're given. Whoops. 3 times x minus 1 squared plus 3. It tells us it does 2 things. A horizontal shift to the left and a vertical shift down. Does it say anything about the A value changing, meaning it gets wider or more narrow? No. So the ones that have it, you can help her. The ones that have a different A value need to be what? Huh? What? No, can't use them. Sorry, couldn't hear you. We can cross them out. Because it completely changed the A value. Now, this is kind of a gimme because it says select all that apply. And I told you that select all that apply means you should have at least how many? More than one, at least 2. Okay? So we know it's both of these, but let's see why. So, in the original, we started with x minus 1. Well, you know that means we move to the, which direction? The right. All right, well, this one down here says x plus 1. So now we've moved back to the, you see what I'm saying? All right, so right here, x minus 1 is at the right. Does everybody agree? All right, but over here on the answer choice, x plus 1 means it moved to the left. All right, now look at the K value. You started with a positive 3, and you ended up with a negative 2. Does that mean you went down?
Yeah.
All right, so that is a choice. Don't put these up yet. Now, the first one. Obviously, the K value went down. We went from 3 to 2. Do we have an X value in the new one? It has to be what if it's not there? Huh?
You said it's not there.
The first one, 3x squared. There's not anything attached to the x, so obviously it's just going to be a 0. Okay? So, we were over here to the right. Now we're at 0. So, do we move left? Yes. Okay? Positive 1 to 0. We went to the left. Okay? All right, let's... I'll finish it and post it. Okay, this is the last one we didn't get to in class. So if you notice, it says the graph is reflected across the x-axis. So remember, the A has to be negative. Then it says it's vertically dilated by a factor of 1.5. So let's go ahead and change the A to a negative because it's reflected. And it tells us 1.5. All right, then it is horizontally translated 2 units to the right. So we take the H and we go 2. And then vertically translated up 4. All right, study this. If you have questions, let me know.